पैकेज है। हम देखिए बहुत अच्छा सा ये बैठे हैं इस पे और ये ऊपर चलेगा अभी। स्क्रीन्स लगे हुए हैं, शायद तो ये चलेगी स्क्रीन्स के हिसाब से। लोग बैठ रहे हैं यहाँ पर।
हम अंग्रेजी में देखने के लिए 1:30 बजे में यहाँ आएंगे। अभी
सुबह के प्रोजेक्टर से एक समय प्रोजेक्टर से चलेगा। प्रोजेक्टर्स लगे हुए अलग अलग। ये लाइफ टाइम एक्सपीरियंस है। शायद तक मैं अपनी ज़िंदगी में दोबारा इतनी क्लोजली सोलर सिस्टम को समझ पाऊँ, देख पाऊँ। पर जिसने भी ये बनाया हुआ है, इट्स अमेजिंग, ए मस्ट वॉच। इवन अगर आप इस वीडियो को भी पूरा देखेंगे, 26 मिनट की 27 मिनट की वीडियो बनेगी ये। उसमें सोलर सिस्टम और इतनी वंडरफुली उसको डिटेलिंग की गई है। लाइव जैसे तो कोई भी रीज़ नहीं है, बट अगर इसको आप बड़ी स्क्रीन पर देखो तो आई होप कि आप भी इंजॉय करेंगे। बच्चों के लिए बहुत अच्छी चीज़ है, डिटेलिंग में बताया गया है। तो जस्ट एंजॉय द वीडियो। मे भी किसी को ये बोरिंग लगे, और जो साइंस में बिलीव करता है, जो सोलर सिस्टम को बिलीव करता है और जो एक्साइटेड है उसके बारे में जानने के लिए, ये उन सब के लिए वीडियो है। जस्ट एंजॉय द वीडियो। मैं इसमें कोई करेक्शन नहीं कर रहा, कोई अल्ट्रेशन नहीं कर रहा, एज इट इज़ बना रहा हूँ। मैंने तो वहाँ पर बहुत अच्छा फील किया। आई होप आप लोग भी फील करेंगे। थैंक यू सो मच। एंजॉय द वीडियो।
Star to us is the sun, so close to us that during the day it outshines all of the other stars. In the 16th century, a Polish astronomer and mathematician, Nicholas Copernicus, came to the conclusion that the Earth and other planets revolve around the sun. Now, officially, our solar system is said to have 8 planets. Compared with other stars in our galaxy, the sun is larger in mass and brighter than average. The sun is designated as a yellow dwarf because of the spectrum of light it emits. Scientists estimate its age at approximately 5 billion years. In the core of the sun, nuclear fusion reactions produce a great deal of thermal energy, which is radiated into space. Besides the thermal radiation, the sun disperses flows of charged particles, called solar wind, which reach all the planets and beyond the borders of the solar system, where it joins with the stellar wind from other stars. Besides the sun, the main bodies in the solar system are the planets, a word derived from the Greek planetes, meaning wanderer. The planets can be divided into 2 groups, inner and outer. Our planet Earth is one of the inner planets, which is why sometimes they are referred to as the terrestrial or Earth-like group. The inner planets have a core of heavy elements, such as iron and nickel, and an outer solid mineral crust. These planets have no rings and no more than 2 moons. Closest to the sun is the smallest planet in the solar system, Mercury. Studded with lots of notched slopes and craters, the planet's surface tells of its hard past, collisions, and volcanic activity. Mercury is rather small, similar in size to our Moon, and smaller than some of the satellites of other planets. It is, however, much heavier than our Moon, because its density is only a little bit less than the densest planet of the terrestrial group, Earth. it can be compared with an iron bead in a thin stone shell. One theory suggests that Mercury once collided with another planet, and in the impact, it lost its external layers. The resulting complete absence of atmosphere on Mercury leads to large temperature changes. At night, the temperature falls down to minus 170 Celsius, warming up to over 400 Celsius during the day. The nearest planet to us, and closer to the Sun, is Venus. By size, it is a bit smaller than the Earth. Thick yellow clouds of sulfur dioxide in the atmosphere of the planet reflect the Sun's light well, making it appear to us as the brightest planet in the solar system. It greets us as the morning star in the east at sunrise and says goodnight to us as the evening star in the west at sunset. The very dense pollution atmosphere of primarily carbon dioxide creates a strong greenhouse effect, retaining the sun's heat and leading to surface temperatures approaching 500 Celsius. The combination of high temperature, atmospheric pressure, strong wind, and lack of oxygen make it inhospitable for life as we know it. The planet's stocks of carbon dioxide are thought to be replenished by ongoing volcanic activity. And here is our home planet, Earth. It's a beautiful planet, with all the conditions for life occurring in a harmonic balance. Vast oceans of water combined with continents of land, and living plants sustain an oxygen-rich atmosphere. Can we use our resources in an appropriate way to maintain this delicate balance and save our only home? The only natural satellite of the Earth is the Moon. Orbiting around us, this quiet neighbor influences not only the ebbs and flows of our oceans, but also, unnoticeable to us, has a surprisingly strong effect on the process in living organisms. Mars. Named after the Roman god of war, Mars has a reddish tint due to the iron oxide or rust prevalent in its surface. For over a century, Mars has been exciting people with its riddles. Its diameter is 2 times less that of the Earth, making it, after Mercury, the second smallest planet in the solar system. On the poles, there are caps of frozen carbon dioxide and water ice, and sometimes frost, and even snowfalls. The winter temperature on Mars' poles reaches minus 153 Celsius, and in the summer on the equator, more than 30 Celsius. The atmosphere contains primarily carbon dioxide and is very rarefied, the atmosphere pressure being 160 times less than that on Earth. At such a low pressure, water can only remain liquid deep in the soil. This was confirmed in 2008 when water ice was found in Martian soil. Evidence of dry rivers and water erosion on the planet's surface give rise to theories that sometime in the past, water flowed and life may have existed. There are vast plains, deep canyons, high volcanoes, and mysterious deep wells to be explored. The planetary soil contains much iron, but theoretically, it has the necessary elements for the origin and maintenance of life. However, the existence of life forms on Mars is still an unconfirmed hypothesis. Two tiny irregular-shaped satellites revolve around Mars, Phobos and Deimos, which mean fear and horror. It's difficult to remain comfortable in a place where the objects are named so unfriendly. So let's move further. Beyond Mars' orbit, there is the asteroid belt. A great number of rocky or metallic objects, sometimes hundreds of kilometers in size. They drift along in orbit, held in place by gravitational forces. At times, they collide with each other, splitting or conversely gathering in a bunch and changing their trajectories. Scientists believe that these asteroids are the remains of protoplanets, the building material of all the planets and bodies of the solar system, which due to the gravity of Jupiter, collided to violently form into planets. Alternative theories suggest these asteroids are the remains of a planet which was destroyed in a collision. The deeper we go into space, the more unsolved questions we have. Having navigated the obstacles in the asteroid belt, let's rush to the outer region of the solar system. At such a large distance from the Sun, planets with less density than the terrestrial group have found their refuge. These are the gas giants. They are all surrounded by rings. Some of them are more evident than others. A majestic giant, Jupiter can be seen ahead. This is the biggest planet of the solar system. Its diameter, 10 times larger than that of Earth, 1,000 times larger in volume, and 318 times heavier. Jupiter consists almost entirely of gases, mostly hydrogen and helium, although it has a solid core. High temperature processes inside the planet and its high rotational speed give rise to hot winds, rushing with huge speed and whisking the clouds of gases in many colored stripes, funnels, and whirls. Inside the clouds, electrical storms rage with lightning 1,000 times stronger than that on Earth. Jupiter's famous Great Red Spot is the biggest storm in the solar system. On Jupiter's poles, the aurora borealis draws its patterns. It is beautiful, isn't it? There are faint rings around Jupiter, which mainly consist of dust and also orbiting satellites. Presently, there are 67 known natural satellites of Jupiter, the biggest among them being the 4 Galilean moons. Callisto, the second largest, is comprised of rock and ices. Ganymede, The biggest satellite is even bigger than Mercury in size. Europa, the smallest of the four, has an icy shell covering a global ocean where life may exist. And Io, the nearest to Jupiter, is covered with active volcanoes. In some respects, these four satellites are similar to the terrestrial planets, with internal heating and volcanoes. Saturn. Named for the Roman god of agriculture, it has an elegant appearance, thanks to its beautiful rings. Its atmospheric structure and magnetosphere are similar to Jupiter, but it has only slightly more than half the volume of its slightly larger neighbor. Saturn has a very low density, less than that of water. Unique among the planets of the solar system, it also has Aurora Polaris, and on its northern pole, a mysterious six-sided formation of clouds, a hexagonal whirl 25,000 kilometers in diameter, which still cannot be fully explained by scientists. Saturn's distinctive rings are very thin, while having a diameter of around 250,000 kilometers, their thickness is less than 1 kilometer. They consist of icy particles with some impurities of tholins, silicates, and carbon, ranging from dust-sized specks to tens of meters in size. Currently, there are 62 known satellites of Saturn, among which the biggest is Titan, the only satellite in the solar system with a dense atmosphere. Titan's surface consists generally of water ice and sedimentary organic substances. Like Earth, there are many lakes, rivers, and oceans on the surface, but they are full of liquid natural gas, not water. If it would be possible to deliver it to Earth, this fuel would be sufficient for the population's needs for thousands of years. Scientists studying this satellite suggest that on the bottom of the basins, the simplest forms of life can exist. Now we face the green and blue planet Uranus. This planet is the lightest planet of the outer group. Uranus is unique in that it revolves laying on one side, like a rolling ball. Relative to the plane of its orbit, its polar axis is inclined by 98 degrees. We also know it has 13 weakly expressed rings of dark particles with diameters ranging from micrometers to a fraction of a meter. At this moment, we know of 27 Uranus satellites. Among them, Miranda, Arion, Umbria, Oberon, and the largest, Titania. And now we reach the most distant planet of the solar system, Neptune. A beautiful planet, it seems blue through telescopes because of traces of methane in the external layers of the atmosphere. Neptune cannot be seen with the naked eye, as it is very far from us. A complete Neptunian orbit around the Sun takes 165 Earth years. In Neptune's atmosphere, the strongest winds of the solar system rage, achieving speeds of 2,100 kilometers per hour. In 1989, the Great Dark Spot, a storm similar to the red spot on Jupiter, was discovered in Neptune's southern hemisphere. By 1994, it had vanished. Now, a new similar storm has been discovered in the northern hemisphere.
और मरण वाले होने देखेगी बेटा
ਮੈਂ ਤਾਂ ਕਹਿੰਦਾ ਮੰਨਦਾ ਨਹੀਂ ਨਾ ਲੱਖ ਰੁਪਏ ਵਾਲੀ ਟਿਕਟ
Neptune has weakly expressed rings and 14 known satellites.
ਇਹ 2 ਲੱਖ ਵਾਲੀ
ਇਹਦਾ ਕੁਝ ਨਹੀਂ है
The largest moon, Triton, accounts for 99.5% of the mass of all Neptune's satellites and is the only one of its moons with sufficient mass and gravity to form a spheroid. The remaining moons have an irregular form. Triton is orbiting in the opposite direction to Neptune's rotation, the only large moon in the solar system with a retrograde orbit. Objects which lie beyond Neptune are said to be in the trans-Neptunian region. These objects include the dwarf planet Pluto, which until recently was considered the 9th planet. Comets, cosmic dust, and meteoroids, all integral elements of the universe. Besides the previously mentioned asteroid belt, situated between the orbits of Mars and Jupiter, there is also another belt of small bodies called the Kuiper belt. It is situated beyond the orbit of Neptune, 20 times wider than the internal asteroid rings, and 100 times more massive. Its bodies are much bigger by size and consist mainly of ices of frozen gases. Although the Kuiper belt is considered the outskirts of the solar system, hypothetically, there is a sphere of objects situated much further from the Sun. Its external border is the maximum distance at which the Sun's gravity can act to attract objects to orbit around it. This sphere is called Oort cloud. Long-period comets, which can sometimes be seen from Earth, are thought to originate from this distant sphere. There is some indirect evidence of the existence of this cloud, but direct observation is complicated by enormous distances, comparative scarcity, and small size of the objects that form the cloud. The solar system strikes us with its scales and variety. But it is only a tiny portion of the galaxy called the Milky Way. Beyond its limits lay a multitude of other unknown galaxies of the immense universe. This is an unbounded world with so much new to get to know. Who knows, maybe someday people will manage to continue their development, not only on Earth, but also beyond its limits.